Okay, so today we're going to talk about parallel and perpendicular lines. We're on page 117 in your packet. Based on your pretest, I know that we have some basic understanding of parallel and perpendicular lines. I know you guys used parallel and perpendicular lines in geometry last year, so these aren't completely new ideas. But I think some of us are maybe a little rusty on how we find those parallel and perpendicular lines. So that's what we're going to talk about today. So on page 117, we're going to start by graphing a line. You know how to do this. You did this a whole bunch yesterday on your quiz. I'm going to start by graphing this line. It's in slope-intercept form. My y-intercept is -2, so I'm going to plot that point. And then my slope is 1/2. Remember, slope is rise over run. So I'm going to rise 1 and run 2. Up 1, over 2. Up 1, forward 2. I'm out of room this way, so I'm going to put some more points back this way. So I'll reverse my slope, down 1, back 2, down 1, back 2. And then I will connect my points and throw my arrows on the end. We're graphing a function, so I want to connect my points and put my arrows on the end. Nothing new so far, just graph the line. The next thing my directions ask me to do to plot the point -2, 3. So -2, 3. I'm going to go ahead and plot that point. And then I want to graph a line through the point -2, 3 that is parallel to the first line. What does it mean for two lines to be parallel? What does parallel mean? Yeah, and you did this with your hands, right? Or yeah. Did you have a teacher at some point tell you, parallel because the L's in parallel are like two lines that are parallel, right? They never touch, right? So the idea behind parallel lines is that they never intersect. You use parallel lines for a bunch of different things in geometry. In some figures, they had properties where sides were parallel, or you used parallel lines and cut them by a transversal. You did all kinds of stuff with parallel lines last year in geometry. When we talk about parallel lines in the context of algebra, okay, where we're looking at equations for those lines, I'm not talking about sides of a figure, but I actually want to be able to describe this line with an equation. Then what we're going to focus on are the slopes of those lines. Parallel lines, we know, never intersect. And the only way to get them to never intersect is if they have the same slope. Parallel lines must have the same slope. So if I'm going to graph a parallel line, it has to have the same slope as my original one. So I know its slope has to be 1/2. So if I go back up to my graph here, I want to go up 1 over 2, up 1 over 2, down 1, back 2, down 1, back 2. Since I'm graphing a function, I'm going to connect those points and throw my arrows on the end. And now I've got some parallel lines. These lines will never intersect. They have the same slope. Okay, they have the same sort of steepness pitch to them. So they're never going to intersect. So last thing I'm going to do is write an equation for my blue line here. Since I know a point on the line and I know the slope of the line, I can write an equation here in point slope form. Now for this particular one, I also happen to have a nice y-intercept. So you could also write slope-intercept form and that would be fine. We're not guaranteed to have a nice y-intercept. So I'm going to do a little review of point slope form here. So my equation would be y equals 1/2, since that's my slope, x plus 2, and then plus 3. That's an equation for my parallel line.
Oh, you put the point, that is your graph in the point in the equation.
Right there and right there are my pieces from my point. Questions for me so far? Okay, turn the page for me. And let's take a look at perpendicular lines. You use perpendicular lines in geometry too. Again, frequently as sort of a property of a figure, you knew that maybe these sides were perpendicular or that some like bisectors were perpendicular, something like that. And that helps you prove things about triangles or quadrilaterals, all that good stuff. In algebra, again, our focus is going to be on that equation. So let's start the same way we did on the last page. We're going to graph, this is actually the same line. We're going to graph this line. My y-intercept is at -2. And again, my slope is 1/2. So I'm going to go up 1 and forward 2, up 1, forward 2 to get some points back this way. I'm going to go down 1 and back 2. I'm going to fill up my graph there. And since I'm graphing a function, I'm going to connect all those points and throw my arrows on the end. And then again, my directions ask me to plot the point -2, 3. So same point we plotted before, -2, 3. But this time I want to graph a line through that point that is perpendicular to our first line. So what does perpendicular mean? They're going to intersect. Perpendicular lines. They intersect, and there's something special about how they intersect. At 90-degree angles. Yeah, they intersect at right angles. Got some people giving me a little T here. Yeah, they intersect at 90-degree angles, at right angles. And that's why you cared about perpendicular lines in geometry, because you had properties of figures that relied on having some right angles. In algebra, when we focus on the ways to describe these perpendicular lines, those equations that we're going to use, we're again going to take a look at the slope, but this time our lines have what we call opposite reciprocal slope. So opposite reciprocal. Let's talk about what opposite reciprocal means. If I want to find the opposite reciprocal, the opposite part is going to tell me to change the sign. So if it's positive, make it negative. If it's negative, make it positive. Opposite means change the sign. Reciprocal means flip the fraction. So if it's 3/4, now it's 4/3. That's reciprocal. Flip that fraction. Switch the top and the bottom. So if my original slope was 1/2, I need the opposite reciprocal. That means my new slope, opposite, needs to change the sign. My new slope will be negative, and reciprocal, flip the fraction, I'll have 2/1. So -2/1 is the slope for my perpendicular line, or just -2 is fine. So this is the slope I want to use for my perpendicular line. So from the point I know, I'm going to go down 2 and forward 1. Down 2, forward 1, down 2, forward 1, down 2, forward 1. As I'm graphing a function, I'm going to connect my points and throw my arrows on the end. So these are perpendicular lines, and when they intersect, they're making right angles. That's the special thing about perpendicular lines. Questions for me so far? Okay, and then just like before, I want to write the equation for this perpendicular line. So again, I know a point and I know the slope, so I'm going to write an equation in point slope form. So this would be y equals -2, that's my slope, or -2/1, that's fine too. -2, and then in parentheses, x plus 2 plus 3. There's the equation for that perpendicular line in point slope form. Questions for me? Okay, there's one more thing I want to do at the bottom of page 118. I'm going to give you some slopes. I want you to jot them down for me. And then I want to practice that opposite reciprocal idea. So I want you to give me the slope of a parallel line and then the slope of a perpendicular line. Here are 4 different slopes. Oops, let me split this a little bit. 4 different slopes. I want you to give me the slope of a parallel line and the slope of a perpendicular line. Give me the slope of a parallel line and the slope of a perpendicular line. Okay, if the slope of our line is 5, what would be the slope of a parallel line? 5, yeah, or 5/1, that's fine too. But it's got to be the same, right? How about a perpendicular line? -1/5. My reciprocal would be 1/5. Good. If my slope is -2/3, what's the slope of the parallel line? I should get everybody on this one. There we go, -2/3. And then how about our perpendicular line? 3/2. It's going to be positive because opposite. We want the opposite sign. Positive 3/2. How about if our slope is 1/7? What's our parallel slope? 1/7. What's our perpendicular slope? -7. Or if you want -7/1, that works too. And then finally, if our line has a slope of -3, what's the slope of the parallel line? -3 or -3/1. And then how about our perpendicular line? 1/3, 1/3. Questions for me for today? Okay, I know you guys have seen this stuff. Most of us did okay on our pre-test with the parallel and perpendicular lines. We knew parallel lines shouldn't touch, and we knew perpendicular lines were going to intersect. Mostly where I saw some issues were with the opposite reciprocal slopes for those parallel lines. Okay, so for homework, and you should be able to get this done during class, you have page 119 and page 120. So you have a little practice up at the top with what we just did. What's the slope of the parallel line? What's the slope of the perpendicular line? And then you have 4 problems to graph. 2 on page 119, 2 on page 120, and then a couple more slope problems. Make sure that you read your problems carefully so you know if you're looking for a parallel line or a perpendicular line. As you're working, if you have questions, make sure you ask, okay? And again, read your problems carefully so you know if you're looking at a parallel line or a perpendicular line.